This video will explain the principles behind our research experiment. The purpose of this experiment is to measure EEG and bbNIRS signals. The first measurement device that we use is called an EEG. EEG stands for electroencephalography, and it measures brain signals. Sensors make contact with the scalp to collect the brain signals. The device we're using in this experiment is called Quick20. It has 19 sensors, does not require gel, and it is easy to set up. So you will not have to wash your hair after use. The EEG measures brainwaves by detecting your brain's electrical activity at different points. This is where we place the sensors, also called electrodes. We can then measure and observe these electrical signals. Different EEG waves are associated with different levels of brain activity. Delta waves, which are the slowest EEG waves, are associated with deep sleep. On the other end of the spectrum, beta waves, which are the much faster EEG waves, are associated with high-level engagement of the brain. The second measurement device that we use is called bbNIRS. bbNIRS stands for broadband near-infrared spectroscopy, and it is an optical brain measurement tool. It measures blood oxygenation in the brain using light. A broad range of light wavelengths is used. Our specific device has 2 light sources and 2 detectors. Like all of our organs, the human brain needs oxygenated blood to function. Oxygen is carried in the blood through hemoglobin. We can essentially measure hemoglobin by looking at the detected color of the light. When you blush, blood rushes to your face and your cheeks turn red. However, if you were to wrap a tight band around your finger, it would eventually turn purple. This is because of a lack of oxygenated blood. So, with the use of bbNIRS, light is shined on the head, some of it is absorbed in the brain, and the reflected light is detected, and its intensity allows us to measure hemoglobin. In the actual experiment, we will collect data from the EEG and bbNIRS at the same time. You'll be in a resting state, which means you won't be performing any tasks. It'll take us up to 30 minutes to set up. Then we'll record your data with your eyes open for 7 minutes, then with your eyes closed for 7 minutes. This graphic shows the full setup. The risk for this experiment is very low. EEG does not emit any signal into your brain. It just collects your brain's natural signals, so it's completely safe. bbNIRS can sometimes create a warm sensation, but this can be prevented by decreasing the intensity of the light. So if you feel any discomfort during the experiment, please let us know. The purpose of this study is to create a better understanding of Alzheimer's disease, potentially leading to the discovery of biomarkers that can diagnose Alzheimer's at an early age. Thank you for your time and for your participation in our study.